Welcome to live.withcode.uk. In this episode, we're interested in combining the theory with the practical Python programming. So particularly interested in calculating download speeds, download times. So if we have a file of any size and an internet connection of any speed, we want to work out how long it will take to download that file. So let's look at this example here. In an exam, you'll be expected to write down an expression, not to calculate. You're not allowed a calculator in the exam, so you don't have to do the maths. You do have to work out what you multiply and divide, add and subtract. So in physics, I hope you've already remembered these triangles. You've got speed equals distance divided by time. And if you want to work out distance, then you can do speed multiplied by time. If you want to work out time, you can do distance divided by speed, etc. Well, if you think about the same thing that you've already remembered, instead of distance, you can have size and then speed and time in one of these magic formula triangles. So if we want to work out the time, we do size divided by speed. What does that mean? Well, if we work out the total size in bits, we've got 22 gigabytes. What on earth are they? Well, remember, kick my granny to pieces. Kibby, mebby, gibby, tebby, and pebby. Each of these are 1,024 times as big as the one above. So Edexcel uses the correct but weird sounding 1,024 multiples for size, rather than what you might be more familiar with, which is the factors of 1,000. So kilo, mega, giga, tera, and peta. So that's going to be times 1,024. Well, we have to go times 1,024 to get to mebby, times 1,024 again to get to kibby, and then another 1,024 to get back to just normal bytes. But remember, 1 byte is 8 bits, so we need to multiply by 8 again. That gives you your total size in bits. You'll get 1 mark for that. Then we've got 54 megabits per second. Notice a lowercase b means bits, a capital B means bytes. You've got 54 and then megabytes per second. Not mebby, but mega this time. The acronyms are in the same order over here, but for speed we use factors of 1,000 rather than 1,024. So in order to get from mega to kilo, that's 1,000, and to get to kilo to just normal, that's another 1,000, so it's 1,000 squared. So you would get 1 mark for 54 times 1,000 times 1,000, and then you'd get your final mark out of 3 for doing the number of bits divided by the total speed. So how can we put that together into a program? Well, we've got something here. Let's see if we can put the right numbers in. 22 gigabytes. 22 gigabytes, which is this many bits in total. And then we've got a speed of, what was the speed? 54 megabits per second. 54 megabits per second. It should download in just less than 1 hour. How does this Python calculate it? Well, the main program bit at the bottom is nice and easy. We get the input as a string. We send that input into this function, which takes a string and converts it into the total number of bits. So let's have a look. Convert size to bits. How does that work? Well, first we take the string and we split it. So we get the 2 parts separately. As in, this parameter here is going to have 2 parts. The value and a space, and then the unit. So we can get the quantity, that's the first part, as in 1.7, by splitting it and taking the first part in the list and converting it to a floating point number. And then the unit is still a string, it's just the second part, as in this here. Then we've just got lots of selection statements. If the unit is any of these, so bits we need to convert, bytes to convert to bits, we multiply by 8. Kibibytes is 8 bits times 1,024. Mebibytes is 1,024 squared, so this is the exponentiation operator for squared. This is 1,024 to the power 3, because that's gigabytes, and the same for tebibytes. And then on here, if it doesn't recognize any of these, it will complain and assume that it's just bits. And we've got the same kind of thing for the network speeds. Very, very similar here. Convert speed in bits per second. It's just if the unit is kilobits per second, we don't have to convert, so we don't have to multiply by 8 here, because we're talking about bits, lowercase b, rather than bytes. So your network speed by your broadband provider will always be mentioned in bits per second, or megabits per second, or gigabits per second, possibly, rather than what you're perhaps more familiar with of bytes per second. And then the last challenge down here, I've got a couple in here. Replace every 1024 with a constant called bytes in kibibytes. You would have to put a constant in here and then use that constant every time you see it, just to make your code easier to read and understand, something like that. This one here is a bit more of a challenge because you've got convert time. This one here, you have a time in seconds, and it just makes it bigger if it's less than 1 whole second, or it makes it a smaller number if it's in minutes, but it doesn't, if it's a very, very long time, I'd like it to say something like 3 hours 27 minutes instead of 183 minutes or something like that.